Okay, let us continue. So this is the afternoon session of the last day of the conference, and our first speaker would be Zhuoke Yang from BIMSA, who will talk about universal polynomial as O and Q weight systems.
Thank you. Thank you, Anton. I'm going to talk about weight system. So first I'm going to talk about this not invariant. So if you have not invariant, you can extend to the not with a simple double point by this Shirliev relations. And if a not invariant is a finite type invariant of order n, if its extension is vanished under all the singularity with more than n double point, and this is very important. This is very strong not invariant, and it's related to this combinatorial object. I call it chord diagram. So chord diagram is just a circle, and you have, if there's order n, it means that you have a set of n disjoint pair of the chords. So you have two endpoints on the circle. So basically, you don't care that it's the overlap, who is upper, who is under. So it's kind of like just a 2n element, and you have pairing and you model rotation. So, and there is a 4-turn element. Is the 4-turn is you have two selected chords, and the fourth is chord diagram. This sum is equal to 0. It's called 4-turn elements, and each Fourier not invariant of all the atoms n is determined the function on chord diagram and vanished on all 4-turn elements. Because that's if the partially not invariant determine order at most n, which means that it is taking value 0 on all the singularity not with n plus 1 double point, and that's exactly means that the value on the chord diagram with n chord. So this function I call it a weight system. So and according to Konservich, 1993, they say that every weight system arises from a certain Vassiliev invariant, which means that all the Vassiliev invariant is kind of like equivalent to the function on chord diagram satisfied Fortran relation. And next is a weight system constructed by Lie algebra. So G is a Lie algebra over C, and they have it has a bilinear form, and we just choose a base EI to ED. D is a dimension, and there's a dual base EI star, E1 star, E2 star to ED star. And you can give a chord diagram with n chord. You just choose a base point on a circle, and they just cut this base point and to move it to transform it as arc diagrams. So I just example that the chord diagram D have 3 chords, and they just cut it under a point that between the green chord and the red chord endpoint. So it's an arc diagram, and you just label each endpoint an element, a base of the element. So first one is the endpoint of the red chord. So I call it EIA, and the next is EIB, EIC, and next you get the second time that's endpoint of the red chord. So you put it EIA star, and you just time this all this endpoint and taking the opposite value of the index into the product. So the weight system WG over D is the summation of the EIA, EIB, EIC, EIA star, EIC star, EIB star, IA, IB, IC. The 3 indexes from 1 to D. So this is an element in the universal enveloping algebra UG. And this result say that the element, the weight system WGD, does not depend on the choice of the base, the base point on the diagram, and does not depend on the choice of the base of the Lie algebra. And also, it's not just elements in the universal enveloping algebra. It is in the center of the universal enveloping algebra. So this shows that the construction is true weight system, which means it also satisfies Fortran relation. This construction is easy to construct, but really hard to compute. So First, let's see that the GLN wave system. So the Liège GLN is, I think everyone knows, it's an n times n matrix, and we choose its bilinear form is a trace of x times y. And we choose the base EIJ is 1, and I0s and J's columns. And the dual base EIJ star is EJI. And the commutation is like this. So, and I want to say that there is a construction of the center of the universal enveloping algebra of the GLN. And then let's see this the example that we have a chord with a singularity knot. And the wave system follow the definition is summation EIJ, EJI, and IJ from 1 to n. And this is exactly the second Casimir element in the center of the universal enveloping algebra of the GLN. And similarly, that the summation of the EII is the first Casimir, and the case Casimir is CK is EI1, I2, EI2, I3, and to go on to EIK, I1. So this is a Casimir element in the center. And the center, ZU GLN, is isomorphic to the ring of the polynomial of Casimir elements. And the higher Casimir elements can be expressed as a polynomial in C1 to Cn. And so this is the definition that's based on the idea of Professor Kazarian. So we can extend the GLN wave system for arbitrary permutation. So for permutation sigma, it's permutated on the set with m elements. And we can define that the GLN wave system over permutation sigma is summation EI1 I sigma 1, EI2 I sigma 2, EIM I sigma m. So this is also an element in the universal enveloping algebra. And we claim that this wave system also lies in the center of the universal enveloping algebra of the GLN. And this element is invariant under the conjugation of the stand cyclic permutation, which is actually not just the element kind of like under an arc diagram, it's like on a circle.
What was the original thing which this is an extension of? Instead of permutations, the original wave system?
Yeah, I mean, you can see. So next, I just want to say that. So so original definition is on the chord diagram. So chord diagram is a permutation with it's kind of only involution of 2n element. So okay. So next is the diagrams. You can draw a permutation as a diagram. So basically, you have an arc from you have a directed edge from I to j if only if sigma I to j. So and then the next is actually the chord diagrams with the n chord, and it says the permutation is only the involution. So 1 to n plus 1, n plus 1 to 1, 2 to n plus 2, n plus 2, 2, and n to 2n, 2n to n. So next example is Casimir element Cm. Based on definition, is summation EI1, I2, EI2, I3, EIM minus 1 IM, IM, I1. So this corresponds to the cyclic permutation. The diagram is 1 to 2, 2 to 3, and m plus 2 to m plus 1. M minus 2 to m minus 1, m minus 1 to m to 1. So the Casimir element is corresponding to this cyclic permutation. And also the chord diagram is a permutation that's evolution without fixed points under set 2m elements. So, and this example that I just drew before. And the theorem is if we consider this generalized wave system, it's easy to compute on the all the permutations. First, so this is the property that this wave system should satisfy. First is on the empty graph, the value is equal to 1. And also it's multiplicative on the, the permutation, you can put two product of two permutations is not the, so you can permutation on the m element and another permutation on the n element, then you can consider it's a product of these two permutations under m plus n elements. And the next is the standard cyclic permutation, correspond to the standard generator CK. And next is just for the graph, it's arbitrary permutation sigma, and you have two neighboring elements. And the difference of you switch these two elements and you can it's equal to the difference of two diagrams with less number of the vertex. So this gives us the recursion relation that we can compute by these rules for every permutation, the value of the wave system. And the special case that if the sigma k plus 1 is k, you can see that they have some C1 and N, the coefficients. And also that this recursion relation, not just for GLN, and it's the same definition for the Lie algebra GLMN for the chord diagram, is also that satisfied the same recursion relation. You just let the C0 equal to M minus N. And next, it's, so this idea is not only just work for the GLN wave system and GLMN wave system. So we're trying to that consider this idea for all other types Lie algebra. So next is we consider this SON wave system. So Xij is the stand generator of SON, and you can define this wave system is you can generalize it to the permutation the same way. And this is a little bit different with the GL case because there's a symmetric on the SO case, and consider a permutation, and there is an independent circle, and you just reverse all the direction of the circle, and you just get a sign factor minus 1 power r. The r is the length of the circle. And also that the same similar rule is following. That's double SO is multiplicative, and they're taking value 1 on their empty graph. Oh, wait. And also I want to say that the structure of the center of the universal enveloping algebra of SON, it is a polynomial of the Casimir elements C0, C2, C4, C6. The order rank, the C1, C3, C5, it's C2k plus 1 is a polynomial of the Casimir elements C0 to C2k. And the next, the generator Cm is only for their cyclic permutation, and the M is even. And the next, the recursion relation is like this. And meaning the first four term is similar with the GLN case. You just switch the two endpoints, R and R plus 1, and then you can do two permutation with the raw number. And the next, you can do, in the graph, it's not even a diagram of permutations. So you see, you have the curve with the double arrow or that without the arrow. So that means that you need to follow this arrow, switch the direction going to the endpoint. And the next four case is that the next four is all possible case, and you need to put a sign in front of these permutations. And this is the recursion relation for the SO. And also that this relation is not just for the SO wave system. This extension is also this recursion relation of this extension on the permutations is also for SP2M and the Lie superalgebra or SPN2M. And the difference is you only need to set the value C0 equal to minus 2M for the Lie algebra SP2M, and the C0 equal to M minus 2M for the Lie superalgebra OSPN2M. And actually, this generation, this extension to the all permutation is not only for the GL, SO, SP, and also for this two infinite series strange Lie superalgebra PQ series. You can also extend it this construction to this two series. But actually, the Lie superalgebra PN has a trivial symmetry, and so this wave system on permutation is also trivial. And for QN system, the QN system permutation is not trivial, but it's also taking value on 0 on all the chord diagram. And even for all the permutation, have at least one circle with even length. So these two cases do not produce the interesting chord diagram wave system. So yeah, that's all I want to say. Thank you.
Thank you very much. Are there any questions?
So for your diagrams, is there any interesting basis you can offer now?
Sir?
Can you offer some interesting basis?
Basis?
Basis. I mean, so you produce using graphics many invariants, right? Many
Yes.
elements in the center. They're of course not independent.
Yes.
So there is maybe some specific distinguished diagram which offer a basis in this space of invariance.
Yes. So, so you mean the diagram? No. So the diagram like this. So it's just for the order permutations. So it's not. It's a representation of the permutations. You just. I don't quite understand what you mean base.
So this diagram defines few elements of the center of the algebra.
Yes.
Yes, but this is space, but it's clearly with some linearly dependence.
Yes.
Can you find some linearly independent which spans the space?
I don't know. I don't know the answer to this question. Sorry.
Okay. Other questions?
So your diagram corresponds somehow making a central element in the universal enveloping algebra.
Yes.
So can you work for affine case? I mean affine Lie algebra?
Sorry.
Can you also working on affine Lie algebra? So you consider infinitely many point in the diagram and consider.
I mean, the definition is. I mean, the original definition of chord diagram is working for the arbitrary Lie algebra, but this is my generation for permutation is now still only work for the GLN, SON, SPN, and all the infinite series of the classic Lie algebra and the Lie superalgebra. So I don't know how to generalize it to arbitrary Lie algebra. No, I don't know. But for the chord diagram, the definition is for arbitrary Lie algebra.
I just wonder about Harishchandra isomorphism. Is it image some kind of shifted SP and other symmetric functions?
Yes. The Harishchandra projection of the SO case, SP case, that they have their formula, but it's a little bit different with the GL case, but basically it's the same thing.
More questions? Okay, let us thank Zhuoke again. And we'll have about 10-minute break before the next talk.